Ladies and gentlemen, I'm Gabriel. Thank you very much for this opportunity which you've given to borrow me your ears. I'll be kindly taking you through paper 1, Mathematics, November 2022, which was not easy as such, or rather difficult, but it was such a standard paper which most of our kids wrote really well. Then let us just go through the paper for the next 30 minutes or so. Now, question 1 we'll have as part of 1.1, we have solve for x, which I know most of our learners, this is when they have more or much of their easily correctable marks. Then 1.1 we had 3x minus 6, then you have x plus 2, then this is equal to 0, this was for 2 marks. Then you have to multiply throughout and have a quadratic expression again, but to rather equate this to 0, where you then have 3x is equals to 6, where you divide by 3 on both sides, then you have x is equals to 2, and the sign you have x is equals to 2 respectively. This was for 2 months. Then you are moving again on to 1.1.2, where you have 2x squared minus 6x plus 1 is equal to 0, where it says correct to 2 decimal places. This is where you have to apply the quadratic formula to have this problem worked out. Then for this one, you have x is equal to 2, or a is equal to 2, b is equal to -6, and c is equal to 1, where x is equal to, according to the quadratic formula, this will be minus b plus or minus the square root of b squared minus 4ac over 2a. Then when this side it will be minus into minus 6 plus or minus the square root of b squared is minus 6 all squared minus 4, a is 2, c is 1, then it's over 2 times a is 2 respectively. Then let me get my calculator over here. Then the side it's gonna be minus 6, and then into minus into minus 6 into, you can put a plus, then it's the square root of minus 6, it is all squared, minus 4 times a is 2, c is 1, and as you go under, it will be 2 times 2. Then the first solution, when we put a plus, it's gonna be, just a moment please. The first solution, when we put a plus, it shall be x is equal to 2.82. 2.82, remember, correct to 2 decimal places. Yes, that's right. And then for the other solution, you have x is equal to, then you will automatically change the sign on the outside. Now we've used the plus. Let us now on the second instant hence use the minus, which together it gives us, yes, it's x is equal to 0.18 respectively. Oh, that's fine. Okay, so that's about it as much as that is concerned. Then question 1.1.3, we have x squared minus 90 is greater than x. Yeah, it's greater than x, 1.1.3. Then for 1.1.3, we have x squared minus 90 is greater than x. This was for 4 marks, the inequality. Then that is to say you'll have x squared, and you transpose the x, it will be minus x, minus 90 is greater than 0. Then together we will then easily factorize without any hassle. Then for x squared we will have x, and for 90 we will have 10 times 9. Now 10 times 9 is 90, but 10 minus 9 is equal to 1x. Then there's a negative sign, meaning the sign should be different, but the bigger number should carry the negative sign. Then this side, to use the equal sign, we will put the critical values, where CV will be equal to x minus 10 is equal to 0, or x plus 9 is equal to 0, and x will be equal to 10, or x is equal to negative 9 respectively. And forget not to write the solutions in the correct inequality notation. Normally I teach my kids to say, when it's like this, allow your sign to have a similar direction as this one, and then make sure the least value is on the left hand side and the bigger value on the right hand side. And the bigger value is the 10 and the least value is the negative 9 respectively. And don't forget to present it in the form of this. And then this is the quadratic function, like a parabolic function, and you'll have it like this respectively. Or we're moving lines together. And now let us now check 1.1.4. Now as for 1.1.4, you have x minus 7 square root x is equals to minus 12. This was for 4 marks. Now these ones is where you remember in grade 11 we'll be dealing with the exponents and surds, which you can put both brackets like this and square both sides and solve for x, or you can simply use the simple rules of factorization. That is to say, if you use the rules of factorization, this will be x minus 7 times x. This is the exponent 1 over 2. Then you can transpose the 12, it will be plus 12 is equals to 0. Then when you have it like this, then you can factorize. And before you do that, it will be x minus 7x to the exponent 1 over 2 plus 12 is equals to 0. Then this over here shall be x to the half, 4 times 3. Now 4 times 3 is 12, and 4 plus 3 is 7. But the positive sign means the signs should be the same and should be both negative. Then we will have x to the exponent 1 over 2 is equals to 4, or x to the exponent half is equals to 3. Then when it's like this, then you can change this into an exponential form. You will continue and write it on this side respectively. That is to say, you have x to the exponent 1 over 2 is equals to 2 to the exponent 2, which you can now write as x to the half. Then it's like we are assuming as if we're dividing by half both of these exponents. So when we divide by half on this one, it will be just x, it will be just 1. Then when we come to this case, it will be 2, and dividing by 2 here, it will be to the exponent 4. Then x will be equals to 16. Then when we move on to the other side, we put an r, and it's x to the half is equals to 3. Then we do the same. We're dividing both exponents, both ends. This is the exponent 1. As we divide both by half, then we'll have x is equals to 3 to the exponent 2. Then x will be equals to 9, which is a good practice, always checking if your values are both correct. But in this instance, I won't do the checking now, but if you take the 16 and you put it here and here, on the left hand side, you'll get a negative 12, and on the right hand side, you'll get a negative 12. Same applies when you take the 9, when you put it here, it will be 9 minus 7. When you put it here, it will be 3. 9 minus 21, it will be minus 12 on the left hand side, and minus 12 also on the right hand side. So when we move further, we will then check 1.2. 1.2 is the simultaneous equation, which was easy that they normally brought it in previous years or in time past. Then you have this side, 2x minus y is equals to 2. Then on the other hand, you have xy is equals to 4. Then this is the equation 1, this is the equation 2 respectively. Then when you choose any symbol, but both of them are simple, like in most cases you have one of the equations being a quadratic equation, but in this both are linear, which you can simply take the first. Then for the first, you'll have 2x minus 2 is equals to y. Then you can have this as equation 3. Then we're going to use the substitution method. You can use the elimination if you want, but most commonly the substitution method is what we normally teach our kids these days, rather than bringing both methods of working this out. Confuse the learners. Then substituting, well, to substitute equation 3 to equation 2, not equation 1, we also take an equation 3 from equation 1, then we're going to as well substitute equation 3 to equation 2. Then which will be x into y is 2x minus 2, then this is equals to 4 respectively. Then when it's like this, then you'll have x times 2x, it will be 2x squared minus 2x is equals to 4. Then as we have it like this, it will be 2x squared minus 2x minus 4 equals to 0. Then as we divide by 2 throughout, this shall give us x squared minus x minus 2 equals to 0. Then when we factorize, this is now easily factorizable than when we had the 2's in there, but it is still one and the same thing. Then this side is going to be x and x, 2 and 1. Then as we factorize, this shall be minus and this shall be plus. Then we'll have x is equals to 2 or x is equals to negative 1. And when you have it like this, there, now we have the two values of x. Now we want to find the values of y respectively. Then we're going to take the same equation 3 to find the values for y. Then that is to say we'll have y is equals to 2x minus 2 or y is equals to 2x minus 2. Then instead of x, we're going to put 2 or substitute 2, where it will be 2 times 2 minus 2, where 2 times 2 is 4 minus 2. Then this y value, the first y value equals to 2, and then as for the other, it will be 2 times the value of x is negative 1 minus 2. 2 times negative 1 is minus 2. 2 and goes like this, 2 times negative 1 is minus 2, then minus 2 minus 2 is equals to minus 4 respectively. That's about it as much as that is concerned. Let us move to 1.3. 1.3 we are to show, they say show that 2 times 5 to the n, show that 2 times 5 to the n minus 5 to the n plus 1 plus 5 to the n plus 2 is even for all integer values of n. Now, as much as this is concerned, now this one is it's an arithmetic pattern. So as much as this is an arithmetic pattern, this is the first term, the second term, and the third term, which you can work out in both ways, in many ways, in a way of saying, as for the constant difference, as you can check this one, is arithmetic, the first value is n, the second is n plus 1, the second is n plus 2, then that is to say, in a way, you can have this subtracting that. That is to say, for the difference, we'll have both of these two. Now, both of these two, then you have 5 into, and as you check, it will be, maybe we check this one, we take 5 to the n plus 2 minus, this one is a minus, so it will be plus 5 into n plus 1. Then if we take a constant difference in this two, it will be 5 to the n times 5 to the 2 plus 5 to the n times 5 to the 1. Then this side it shall be 5 to the n into, then this shall be 25, which is the same as 5 to the 2 plus 5 to the 1, which is 5 to the n into 25 plus 5. Then this side it shall be 5 to the n, then this side 25 plus 5. Then 25 plus 5 it will be 30. Then it will be 30. Then if which 30 is an integer or 1, somebody may also use the other case and simply factorize this even from this point over here. It will still give the same, that is to say, or if you factorize this one over here, it shall be 2 times 5 to the n minus 5 to the n times 5 to the 1 plus 5 to the n times 5 to the 2. That is to say, you have a common factor of 5 to the n into 2 minus 5 plus 5 squared. Then it will be 5 to the n into, then this shall be 2 minus 5, then 2 minus 5, it will be minus 3, then minus 3 plus 25, then this 5 to the n into 22, which is still an even number, So that's about it as that is concerned. Now, let us move again, gentlemen, to 1.4. Then as we move to 1.4, 1.4 we have this is based on the exponents for grade 11. Then this for the exponents. Then we have 1.4, which is so interesting. Then so as for 1.4, we have this respectively. It's 3 to the exponent y plus 1. But if you have the question paper together with you, we'll just surely move together. Then we want to check again this 1.4 respectively. Now, as for 1.4 we have, it says determine the values of x and y if 3 to the exponent y plus 1 over 32 is equals to the square root of 96 of the x. So this one we can solve it in two different ways. That is to say, one can equate simply this one, or rather cross multiply. So in cross multiplication, it will be 3 into y plus 1 is equals to 32. 32 times the square root of 96 to the exponent x, where this will be 3 to the exponent y plus 1 is equals to 32. We can write it as 2 to the exponent 5 times this one is 96 to the exponent x over 2. Now x over 2 is the same as 1 over 2x, which is 3 to the exponent y plus 1 is equals to 2 to the exponent 5 times this one. We can write it as 24 times 4, but let's make a point that we put it all in brackets. Now, x over 2 is the same as 1 over 2x, as we said earlier. Now, 3 to the y plus 1 will be equal to 2 to the exponent 5 times this. 24 will break into 8 times 3 times 4. It still gives us 8 times 3, 24 times 4, still 96. Then we will still put it under the same exponent, which is a half of x. Then y plus 1 is equal to 2 to the exponent 5 times. This we can now break to 2 to the exponent 3. Now all these are to the exponent 1, so when they multiply that, they will give us something very interesting. Now this one will be 2 to the exponent 3 times half x, so it will be 2 to the exponent what? 3. Now 3 times half, so it will be 3 over 2x. And this side it will be 3 times the exponent here is 1. 1 times half, so it will be 3. 1 over 2x times this one over here is 2 to the exponent 2, which will simply write it as 2 to the exponent 2 times a half of x. Then as we continue, it shall be 3 to the exponent y plus 1 is equal to 2 to the exponent 5 times 2 to the exponent 3 over 2x times 3 to the half x times 2 to the exponent this and this, it will be just 2 to the exponent x, just like that, respectively. Now we are going to equate. Then now, equating first, we can take, even if we can take only the x's, we can take the x's and only those which are having the basis of 2. Now those having the basis of 2, we have, for the basis of 2, we have 2 to the exponent 3 over 2x, then it's times 2 to the exponent 5, it's times 2 to the exponent x. Now we will take these exponents and we will only equate them to 0. That is to say, it will be 3 over 2x plus 5 plus x is equals to 0. But when we equate these two, it will give us, and let us continue to decide. Then when we add 3 over 2x plus 5 plus x, it will be 3 over 2x plus x is equals to minus 5, where both of these will give us 5 over 2x is equals to minus 5. Then when we divide both sides by 5 over 2, it shall be x is equals to minus 5 over 1 times 2 over 5. Then x will be equals to negative 2. X is equals to negative 2 respectively. And then, but as for y, then we're going to look at the side. We will then equate only those that are having the basis of 3. Then, which is 3 to the y plus 1, and it's only one entity on the right hand side, which is 3 to the exponent half of x.